Let's do a problem that kind of corresponds to that picture above. A wagon is pulled 100 meters along a horizontal path by a constant force of 50 newtons. So when you see newtons right away, you know, oh, newtons, that's used in the metric system, right, for force, 50 newtons. So that's the force. The handle is held at an angle of 30 degrees above the horizontal. And we're assuming horizontal ground here. So find the work done on the wagon. So let's label some stuff here. What's the 100 meters? That's the distance from P to Q, so that's 100. 100 meters. Make sure you're in meters, right? Because you have to make adjustments. So if it were 1 kilometer, how would you want to write it? 1,000 meters. So a wagon is pulled 100 meters. Got that? 50 newtons. That would be the force, the length of the force vector, really. So magnitude of F is 50 newtons. And then what's the other critical thing we have? The angle along the horizontal is 30 degrees. So in the homework, when you realize what you're given, and by the way, you don't need to draw this picture. I just did it for fun. You have to figure out, okay, what am I given, and then which one of these formulas is the best one to apply? 1, 2, or 3? 2, because we know the magnitude of F, we know the magnitude PQ, we know the angle. I mean, you could try to apply number 3, but then you'd have to come up with the vectors, the appropriate vectors, and that would be no fun. So we're going to use the formula work is equal to magnitude F, magnitude PQ, cosine theta. Fill it in for me. What do we get? So that would be 50 times what? 100, I think I heard. Guess I don't need those parentheses if I use, maybe I better not use a dot. It's not the dot product, right? And then cosine of 30. Anybody remember what the cosine of 30 degrees is? Root 3 over 2. So that would be 50 times 50 out front. What's that? 2,500 root 3. And what units are we in? Newton meters or joule. You could put a big old J for joules.